Welcome to this week's instructional video. I'm planning on doing a weekly video in which we cover different concepts which you might need to know in order to use your incubator or to troubleshoot your incubator, and hopefully we can offer some good advice and we can help some people increase their hatch rates and their profitability. So in this week's video, I'm going to talk about calibrating your digital incubator controller. And I'm going to start with this one because I've seen quite a few people online asking what calibration was, how calibration should be done, and what tools are required. I've also seen some people stating that their controllers don't require calibration because they are in fact self-calibrating. Now, I can assure you that no digital controller is self-calibrating. So if you are not calibrating your own controller, your controller is not reliable and it is not accurate, and that could possibly be what is to blame for a low hatch rate. So I'm going to discuss in detail why we have to calibrate, when we have to calibrate, and I'm going to show you a demonstration of how we calibrated one of our own machines recently. So I want to just talk about why we need to calibrate our incubator controller in the first place. And the reason is because a lot of people put quite a lot of trust into the incubator controller because they are computerized digital devices. Now, the thing we need to realize is that our controller cannot measure temperature, nor can it measure humidity. So in order for us to control the temperature and the humidity using our controller, we have to first attach a sensor. And the job of the sensor is to respond to the temperature and then send a message back to the controller as to what the temperature actually is. Now, the advantage of our sensors are that they are very easy to interface with our controllers. Very, very simple. On the other hand, they are also very precise. So in the case of a temperature sensor, they can respond to temperature changes of as little as 0.1 degrees Celsius. And on the other hand, they respond very quickly to temperature. So unlike a mercury thermometer, which climbs very, very slowly, your digital sensor will respond much, much faster. Now, the disadvantage of a sensor like a temperature sensor or a humidity sensor is that they are not completely reliable. And what I mean by that is, if we were to buy 50 temperature sensors from the same manufacturer at the same factory, and we put them inside of an incubator which we know is 37.5 degrees Celsius, and I measured the temperature in my incubator 50 times using each one of those 50 sensors, I would probably get 50 different temperature measurements. And my temperature measurements will range anywhere from 36 degrees Celsius all the way up to 42 degrees Celsius. Now, the reason why our sensors are so inaccurate is because when they manufacture them, they cannot manufacture them perfectly. So some sensors will be a bit longer, some a bit shorter, some a bit thicker, some a bit thinner. And so we would have to take these differences into account when we analyze the message coming back in order to get the correct temperature. Now, that wouldn't be terribly difficult to do because they would be able to account for that at the factory. But to make our lives a little bit more difficult, the age of the sensor also plays a very crucial role in the temperature measurement or the humidity measurement that it gives you. So you may find that a temperature sensor may be accurate today, and in 2 months' time, it would be wildly off, and it could potentially be measuring a temperature 2 degrees higher than what it used to when we bought it brand new. So in order to account for the manufacturing error and the age, we have to come back to our controller every time we hatch, and we are going to have to determine whether our temperature and our humidity measurement is still reliable. And if the accuracy or the reliability of those sensors has changed and it is no longer reliable, we need to assist the controller into adjusting the temperature and the humidity measurements either up or down in order for them to give us an accurate, reliable measurement once again. Okay, so here we are in the hatchery. We're about to load 5,000 eggs into the setter hatcher. But before we do that, we are going to calibrate our controller to make sure that it is in fact accurate. So to do that, we need to first determine what the real temperature and the humidity in our incubator is, so that we can compare it to our controller and we can then work out whether our controller is in fact correct or not. And if our controller is incorrect, we need to adjust those measurements so that they become correct. Now, a lot of people ask me, can we use a digital thermometer hygrometer which they bought online, or a data logger? And my answer to you would be no. The reason is because your data logger and your thermometer hygrometer are made of the same components as your controller. And so they have very much the same problems. And so not only do you have to calibrate your incubator controller, but if you intend on using your thermometer hygrometer and your data logger in your incubator, you have to recalibrate those as well. Now, a wet and dry bulb thermometer like this, on the other hand, gets calibrated at the factory, and unlike our digital controllers, they are not prone to drift. So where your digital controller loses accuracy with age, your alcohol thermometer will not. And so we can accept any measurements coming off an alcohol thermometer such as this as being reliable and being accurate, and we will use those as the numbers which we will calibrate our controller to. Now, unfortunately, I wasn't able to film the wet and dry bulb through the window with enough detail to be able to take a measurement with the camera. And so what I'm going to do for you is I'm going to animate the wet and dry bulb on the right hand side of your screen so that you can see what the wet and dry bulb was doing inside the machine at that time. Now, my first step is I want to calibrate just the temperature. Right now I'm not going to worry about the humidity. We'll come to that later. So there you can see my controller is programmed for 37.5 degrees. And so whether my controller is accurate or not, my controller will heat the machine up to what it believes to be 37.5. Now, what I would hope to happen is I would hope that my controller's dry temperature, the 37.5, would in fact match my dry thermometer on the right side. Because as I said to you, I can accept the dry bulb thermometer to be correct. And so if my controller shows me anything different to what my dry bulb thermometer does, then it means my temperature controller's temperature measurement is wrong. And I need to then adjust my measurement on my dry controller so that it matches the dry thermometer on my alcohol thermometer. Now, what you're going to see happen here is my alcohol thermometer settled on 40 degrees Celsius. Okay, so I can tell you with reasonable certainty that the temperature inside my incubator was in fact 40 degrees Celsius. And if I was to put eggs in this machine now, 5,000 eggs, I would expect all the egg embryos to die within the first day, because that is way, way above what I would expect an egg to be able to survive. So before I put any eggs in this machine, I need to fix this inaccuracy on this controller. And to do that, I'm going to take my dry bulb thermometer temperature, which is 40 degrees Celsius, and I'm going to subtract the temperature on my digital temperature controller, which is 37.5. Now, why I do that is because I need to determine by how much I need to increase my temperature measurement on my controller. And you can see that that difference is 2.5 degrees. So by default, my controller measures 37.5. And so what I need to do is I need to tell the controller that from now on out, because of error, I need it to add 2.5 degrees onto every temperature measurement before it displays a temperature measurement on the screen for me to see, or that it uses in order to actually turn heaters on and off to adjust temperature. Now, with an XM18 controller, the value we need to change is in fact the F5 value. Now, to get to the F5 value, all we have to do is push the set key, hold it in, and then tap just the down key. And you will see F1 appear in the bottom right hand corner. Now, F1 would be the value, the 90 would be the property value, and the 90 is in fact the turning interval time. So by changing different F values, you can change how your controller behaves. But the value I'm interested in here is the F5 value, because that is my temperature calibration value. And whatever I type in here will be added to the default temperature of the controller. And it will then push the temperature measurement of my controller up. And to get to 40 degrees Celsius, I need to add 2.5 degrees. And so I'm going to push the up arrow key until the value for F5 is 2.5. And I'm then going to push OK to accept. And what we expect to see, if you did this correctly, the temperature of the controller will rapidly increase up to 40 degrees Celsius. Now, it's important to notice that my temperature in my machine right now is actually not going up. My temperature is actually staying the same. The reason why we see this is because the controller has only just figured out that in fact the temperature is 40. And so it displays a new temperature of 40, which matches my dry bulb thermometer. And you'll see that your alarm light comes on, your extraction fan light turns on. Hopefully you have an overtemp inside your machine. That should kick in. And the controller will now slowly bring your temperature back down to what 37.5 is based on its new measurement. Now, what we would expect to see as well is the temperature on our dry thermometer should also come down together with your digital controller. And unless your controller has a problem, we would expect that both the controller's temperature will settle on 37.5, and we would expect that the dry thermometer on the right hand side also drops down to 37.5, which you can see on the thermometer now matches. Now, we've now got to a point where our calibration is correct on temperature. We can see that the digital controller and our dry thermometer is the same. And we can now move on to the humidity calibration. Now, the humidity calibration, we are going to do exactly the same thing we did before on the temperature. We are going to determine what the real humidity is. We are then going to determine what we have to do to the controller value to make it the same as the correct value. And we will then adjust the F6 value this time, because F6 is my humidity calibration value. Now, in order to determine what the real humidity is, it's slightly more complicated. I've seen them come with spreadsheets. Some of them come with code wheels, but I found them rather cumbersome. And so what I did is I made a free online tool which you're welcome to use. If you go to www.country-house.coza, in the main menu you will see an option for tools. And if we go to the tools menu, you'll see an option there for calibration calculator or humidity calculator. And we will use this calculator to convert our wet and dry bulb values into a humidity. Now, as you can see here, it's asking you for certain information, such as your dry bulb temperature, which is your left-hand thermometer. It wants your wet bulb temperature, which is your right bulb thermometer. And it also asks you for altitude. That is optional. If you know your altitude, it will just give you a little bit more accuracy, but if you don't, you're welcome to leave that at 0. It's not a problem. So we can see here that my dry thermometer now is showing 37.5 because we in fact calibrated the temperature correctly, and the controller is now maintaining what we expected to maintain. And so in the first box we're going to type in 37.5 degrees Celsius, and then in the second one, the wet bulb thermometer, you can see is at 27. So we will type in 27 degrees Celsius, and we will then push the calculate button. And you can see that my humidity calculates at 44%. And that is way, way too low. And so what I need to do is I need to adjust my controller's humidity measurement to go from 55 down to 44%. Now, in order to do that, I need to subtract 11% off the current humidity measurement on my controller. And if I do that correctly, I would expect the humidity measurement to drop down to 44%. Now, in order to change my humidity calibration, I'm going to again push and hold the set button. I'm going to then push the down arrow key. That will go to the F menu. I will push the OK key to go to the F6 value, which is my humidity calibration value. And I'm then going to push the down arrow key so that I can change this value to -11. And so from now on, it will reduce all its humidity measurements by 11%. And again, if you did this correctly, you would expect the humidity measurement to plummet down to 44%, which it does. And the controller has now figured out that the humidity is in fact too low. And so you will see that an alarm goes off to warn you about low humidity, and it turns on our wet heater in order to get the humidity up. Now, I'm going to give it another 30 minutes, and you will expect to see that humidity measurement to go back up to 55. Now, as the humidity increases, you'll also see the wet bulb thermometer, the temperature also increases. And you'll see that the temperature on my wet bulb has gone from 27 degrees Celsius up until 29. So by doing that, that means that in fact my wet and dry bulb is telling me that the humidity has been climbing over the last 30 minutes. Now, all I want to do before I load my eggs, I want to double check that in fact my controller is now giving me the correct humidity. And so I will go back to the Country House website, and I'm going to backspace out the 27 degrees Celsius, and I'm going to now change that to the new temperature, which is 29. And if I click on the calculate value, you can see there that it is now measuring 53%. Now, I wouldn't be too tied up with trying to get terribly accurate with the humidity. If my controller is measuring 55 and the real humidity is 53, that would be a suitable accuracy. I would be more than happy to put my eggs in the machine. So by doing this, we've now checked our incubator controller. We've identified that it was wrong, and we have now corrected the values. We've corrected our incubator measurements, and we've now compared them finally with our wet and dry bulb, and they do match. And so I can now safely say that my incubator is operating correctly. And it's worth mentioning that had I skipped this step and loaded 5,000 eggs into this incubator, my hatch rate probably would have been close to 0%, if not 0%. So I hope this has been helpful to somebody. Hopefully it solves your problem, and thanks for watching.